Alrighty, so it's a lot more than you think it looks like. All right, once we fill out this chart and know how to use it, everything comes pretty breezy. Now this says, identify whether the graph has a positive or negative leading coefficient and an odd or even degree. So we're going backwards. So now I know what my graph looks like, and I want to tell what I know about the leading coefficient, your LC, and your degree. Well, we can only tell based on the end behavior. So the end behavior, we're always going to go to based on the right side of the graph. The right side of the graph is going up, right? The right-hand side is going up. So let's go back to my chart and see what we know. When the right-hand side's going up, that's written over here in orange. That means I must have a positive leading coefficient. So my leading coefficient is going to be positive. So I answered that question. And then it says whether I determine whether I have an even or an odd degree. Well, my ends of my graph are doing opposite things. One's going up and one is going down. So I know that they do opposite things when they have an odd degree. So it's going to be an odd degree. Okay. All right, over here, I can do the same thing. I'm always going to start looking at the right-hand side of my graph. And here, the right-hand side of my graph is going down. So when my right-hand side of my graph goes down, I know that my leading coefficient is negative. But both of my graphs are facing the same direction. My graphs are both going down. They're doing the same thing, so that must mean that they are the same, which means that they are going to be even. So that's how I know that. Okay? Then I have one last thing. It says identify the end behavior of the polynomial in factored form. Whoa, looks like a lot, but it's not. We need to figure out, though, once we FOIL all of this together, we need to figure out what the leading coefficient is so that we can say what our end behavior is. Easy. We're only going to multiply the first thing in each binomial together. So we're only going to multiply those things together and start with 2 at a time. I'm going to multiply negative x times 5x. Alrighty. Well, every time we multiply x's together, the exponent goes up by 1. So negative x times 5x. Well, negative times 5 is a negative 5. And x times x is x squared. Okay. Now I've done that. I've cleaned up those two. Then I'm going to multiply it times 3x. I'm going to multiply it by this now here. Okay. Well, you're going to multiply the numbers by the numbers. Negative 5 times 3 is negative 15. And then x. And then again, we go up an exponent. 2 x squared times x, that goes up an exponent. So that's going to be x to the third because we're adding our exponents. 2 plus an exponent of 1 is 3. All right, that took care of that. Now I'm going to multiply it by this last thing here, which is negative 3x. Multiply the numbers first together. Negative 15 times negative 3 is positive 45. X, and then remember my exponent's going to go up again by 1. X to the third times x is x to the fourth. Now I know the leading coefficient is going to be this. My first term is going to be this. I don't care about everything else because I know what the end behavior is going to be. So I know that my leading coefficient is positive. And my degree of 4 is even. I know what happens with the end behavior. I know that a rough sketch of my graph, a positive leading coefficient means that my right side goes up, and even means that the right and the left do the same. So I'm going to write the end behavior based on this graph right here. Okay, and so you may need to watch one last video.